Problem 1 part A asks you why the specific heat at a constant pressure and the specific heat at a constant volume for an ideal gas are related by a shift of the gas constant R. Well, to understand that, the book actually does a pretty good job of explaining this in the form of an equation. So, the thermal energy for an ideal gas is defined as work plus heat. For an ideal gas at a constant volume, which is also known as an isochronic process, does not have a changing volume, and this can be seen as a gas chamber without a moving piston. This basically means that the gas can apply no work on its surroundings, since work is defined as a force over distance, and since that piston isn't moving, aka the volume isn't changing, no work can be done, so work is zero. So then the change in thermal energy for an ideal gas at a constant volume is just defined by its heat energy, which is calculated by NCV delta T. However, for a gas at a constant pressure or an isobaric process, we know that work can be done in the environment because the piston is allowed to move, meaning that we can define our equation as negative PV, which is how we calculate work for a gas, plus NCP delta T. And these two thermal energies for the ideal gas at a constant volume and an ideal gas at a constant pressure are actually equal to each other, meaning that we can equate their definitions. So equating the two definitions gives us NCV delta T equals negative PV plus NCP delta T. To simplify this further, we can substitute in negative P delta V for negative nRT by using the ideal gas equation, which states that PV is equal to nRT. From here, we can cancel out the moles and the change in temperature since they are all the same throughout all our terms. This leaves us with CV, R, and CP. Rearranging the equation, we get a final equation of CP is equal to CV plus R. To explain this in a more general sense without all this math, the reason why we have a difference of R here is because of the different processes the gases will have. For a constant volume, no work is done. So we don't take into account that negative PV that is taken into account in that change in pressure, and that negative PV attributes to the R constant found in our formula. Part B of this question asks, explain why equation 19.32, which relates to change in thermal energy to specific heat at a constant volume, does not contradict the definitions of a specific heat for an ideal gas, 19.24. 19.24 basically states that heat is equal to moles times the specific heat at either a constant pressure or a constant volume times a change in temperature. This doesn't contradict it because the difference between pressure and volume is the work. Since the gas at a constant volume doesn't apply work and the pressure does, we can define them differently in terms of thermal energy rather than heat. The heat will be calculated in the same way, with NC delta T. However, with work added into the equation, we get a difference of R between the specific heats, and is the reason why it doesn't contradict the original equation that we calculated earlier. Anyway, that's all for me for now. Thanks for watching.